We now discuss the solution of a problem from the section Coordinate Geometry, and the problem is on the mirror image of a given parabola. This question has appeared in the joint entrance examination main held on 24th June 2022 in the second shift. The problem is, let P1 be a parabola with vertex 3, 2 and focus at 4, 4, and P2 be its mirror image with respect to the line x plus 2y is equal to 6. Then the directrix of P2 is x plus 2y is equal to, we are given a parabola P1 whose vertex is at 3, 2 and focus at 4, 4, and P2 is given to be the mirror image of P1 with respect to this line x plus 2y is equal to 6. Required to find the directrix of P2. In that, x plus 2y is given, and it is, you have to find x plus 2y is equal to dash. We now discuss the solution of the problem in detail. We have a parabola P1 with vertex V with coordinates 3, 2 and focus F with coordinates 4, 4. So that is our parabola. This black point is V 3, 2 and the red point is F 4, 4. Then the line joining V and F is the axis of the parabola P1. So this green line, that is the axis of the parabola P1. The slope of this axis of P1. So how do we find the slope of this axis? And it is the line joining the point 3, 2 and 4, 4. Therefore, its slope will be y2 minus y1 by x2 minus x1. That is 4 minus 2 by 4 minus 3. That is 2 by 1. That is equal to 2. So the slope of the axis is 2. And given a line L whose equation is x plus 2y is equal to 6. And how is this line with respect to this line? Where is this line? That is the question. So what we see is, we see the slope of this line L. That is, let us say M2. And the slope of L will be y is equal to minus x by 2 plus 3. So therefore M2 will be minus 1 by 2. Now what we see, M1 multiplied by M2 is minus 1. 2 into minus 1 by 2 will be minus 1. So therefore, how this L will be? L will be perpendicular to the axis of P1. So since M1, M2 is equal to minus 1, the line L is perpendicular to the axis of P1. That will be like this. So this is the P1. This is the line L. Now, given P2 is the mirror image of P1 with respect to the line x plus 2y is equal to 6. That means in this, the mirror image you have to take. So now P2 is a parabola. Why? Because P2 is the mirror image of P1 with respect to this line x plus 2y is equal to 6. So P2 is also a parabola. So that is like this. And we have to find the directrix of this parabola P2, this mirror image P2. So to do so, we first should know the directrix of the given parabola P1. If we get the directrix of the given parabola P1, then the mirror image of that directrix of P1, let us say D1, will be D2. That will be the directrix of P2. So that is the method of finding the directrix of P2. We continue. Now, the directrix D1 of P1 is perpendicular to the axis of P1. Yes, obviously. The directrix, let us say D1 of P1 will be perpendicular to always to its axis. So it will be, so D1, so it is perpendicular to P1, but how L is there? L is perpendicular to P1. L is perpendicular to P1. D1 is perpendicular to the axis of P1. Therefore, D1 is parallel to L. So L is perpendicular to the axis of P1, correct? And D1 is perpendicular to the axis of P1. Therefore, they must be parallel. D1 is parallel to L, that is x plus 2y is equal to 6. So where is D1? D1 we have to draw. So we have the directrix D1 of P1 which is parallel to the line L, x plus 2y is equal to 6. Yes, now the directrix has come. This is the blue line, that is D1. This is the line L. This is the vertex V. This is the focus F. And this is the mirror image. This is P2. This is P2. So now the equation of D1 is, because it is parallel to L, and the equation of L is x plus 2y is equal to 6. Because it is parallel to L, the equation of D1 will be x plus 2y is equal to k, where k is a constant to be determined. So to determine this constant, we will use the definition of a parabola. So by the definition of parabola, the distance between V to F is equal to the distance of V from the distance of V from the directrix D1. That means the perpendicular distance of the point V on D1 is equal to the distance between V to F, and V is 3, 2, F is 4, 4. So what will be the distance between V to F? That will be under the square root of 4 minus 3 whole square plus 4 minus 2 whole square. And what is the perpendicular distance of V on L? L is x plus 2y D1 on D1. D1 is x plus 2y is equal to k. So x plus 2y minus k on that perpendicular distance from V is 3, 2. So that will be modulus of x, that is 3 plus 2 into 2. 2 into 2 minus k here it is. X means 3 plus 2 into 2 minus k by under the square root of the coefficient of the square of the coefficient of x, that is 1 square, plus the square of the coefficient of y, that is 2 square. So this is the perpendicular distance. So this will be, when simplified, this will be root 5. And when simplified, this will be modulus of 7 minus k by root 5. Now cross multiply, we will get modulus of k minus a is equal to root 5 into root 5, that is equal to 5. That is k minus 7 is equal to plus or minus 5. So then we will get the value of k is equal to 2 or 12. So in this, we reject the value for k to be 12. So suppose you take k is equal to 12, then d1 will become x plus 2y is equal to 12. So now k not equal to 12. Why? Because if you take directrix equation x plus 2y is equal to 12, then 4, 4 satisfies this equation. 4 plus 2 times 4, That is 8 plus 4, 12. It passes through the focus. That means the directrix is passing through the focus, which is absurd. Which is absurd. Therefore, therefore, k cannot be 12. So k is equal to 2. So the directrix d1 of p1 is x plus 2y is equal to 2. So the equation of d1 is 2. So how do we find the directrix of the mirror image of this parabola in this line L? For this black one, this is the parabola. What is the directrix? Directrix will be somewhere here, somewhere here. And to find that one, what we see is you take the directrix d1 of p1 and take its mirror image in the line L, then that will be d2. That will be the directrix of p2. That we will do it in the next slide. We have the equation of d1, which we have just seen, x plus 2y is equal to 2. Given p2 is the mirror image of p1 with respect to the line L, that is x plus 2y is equal to 6. So p2 is also a parabola, and so this is how we have already seen this. And the directrix d2 of p2 is the mirror image of d1, that is x plus 2y is equal to 2. This is d1 with respect to this line L is x plus 2y is equal to 6. So this is the one. This is the one. So the mirror image of d1 with respect to the line L is d2. So we have to find the mirror image. So now d2 is given by, because d2 is a mirror image means it is parallel to both d1 and L. So whose equation will be x plus 2y is equal to c, where c must be greater than 6. Why? L is already x plus 2y is equal to 6 and d1 x plus 2y is equal to 2. So that means x plus 2y is equal to 2, x plus 2y is equal to 6. D2 equation will be x plus 2y is equal to c, that c must be greater than 6. And in what fashion it will be? It is a mirror image. Mirror image means the distance between L and D1 must be equal to the distance between D2 and L. D2 and L. This distance is equal to this distance. That you have to compute. Now that is modulus of c minus 6. That means x plus 2y is equal to c, that is d2. L, x plus 2y is equal to 6. The distance is 6, c minus 6 by under the square root of 1 square plus 2 square. So what will be the distance between uh, L and D1? L and D1. It will be 6 minus 2, modulus of 6 minus 2 by under the square root of 1 square plus 2 square. So 1 square plus 2 square, this denominator will be cancelled, and modulus of c minus 6 is equal to 4. So what is c greater than 6? Therefore, the c must be 10. C must be 10. Because c is greater than 6, c must be 10. So c is 10 means we have found D2 equation. That is the directrix of the mirror image, that is P2. So x plus 2y is equal to 10 is our answer. The directrix of P2 is x plus 2y is equal to 10. So we have to fill up the blank. So x plus 2y is dash is given. In the dash, this is 10. So our answer to this question is 10. I am sure that you have understood the solution of this problem, and it is certainly a very important problem. I wish you all the best. Thank you.